Hello dear students, myself Dr. Girish Gun, Assistant Professor at the Department of Physics, Mahatma Phule Arts and Commerce College, Panvel. Today I am going to talk about the crystal physics and some of the articles from the crystal physics. So especially I will today tell you about the crystalline state and the basic definition of the crystalline lattice. Okay. So coming to the phase of the matter, we know there are mainly three phases of the matter or state of the matter, which is nothing but the solid, liquid and gas, which has been shown over here. So from over here we can see how the arrangement of the atom is there into the solid, how the liquid is there and how the gas is there. And this below figures told us about the how the solid, liquid and gas is fitted into the container. So we know the solid has its own shape and size, right? And liquid can have the shape of the container in which we pour it. Then the gas has the property to acquire the complete volume or the complete space of the container. So solid has its own shape and size. Liquid can acquire the volume of the container, shape of the container in which we pour it, and then gas can acquire the complete volume, complete space of the container in which we put. Then the question comes in our mind is why these phases or these states of the matter is does in exist. So simple reason behind this question is that the interatomic, intermolecular forces that exist between the atoms or the molecules within these three different phases. So like in a solid, we know the interatomic force is very strong. Then coming to the liquid, intermolecular force is comparatively low than the solid, and when we come into the gas, this intermolecular force is almost negligible or it is almost zero. So that is why the solids have its own shape and size. So as intermolecular forces is very high, so it packs the atoms, ions or molecules together and make the solid. And coming to the liquid, as the intermolecular forces into the liquid is comparatively low than the solid, so they can flow. Okay, so they can flow from the higher pressure to lower pressure. And into the gas, we know it can acquire the volume of the container. If volume of the container is smaller, so it can acquire the small volume. But if we increase the volume of the container, the gas will acquire the whole volume of that container, because there is no or very low interatomic of forces or intermolecular forces. So gas will expand according to the space available to it. So this is about the different phase, different state of the matter. So solid, liquid, gas, these are the mainly three phases of the matter. Now as we are going to study about the crystal physics, or we are going to focus on the crystal physics. So crystal physics is a branch of the physics which deals with the study of the solids. So we will focus now onwards about the solids, and we know the solid has been classified into mainly two states or the two types. That is, one is the crystalline solid and another one is the amorphous solids. So then question comes, what is the difference between the crystalline solid and amorphous solid? This difference exists into their arrangement of atoms. I mean the difference does exist into how the atoms or molecules has been arranged into the space for that particular type of a solid. So like in a crystalline solid, we know the arrangement of atoms or molecules from which this solid made, so or it has been created. So that atoms or molecules has been arranged in a regular manner into the three-dimensional space. So this is about the crystalline solid. When we coming to the amorphous solids, this regular arrangement has been interrupted, or this atoms, molecules or ions has been arranged irregularly into the three-dimensional space. So crystalline solids are the substances whose constituents, atoms, molecules or ions has been arranged in a regular manner into the three-dimensional space, whereas the amorphous solid is the substance in which the constituents, atoms, molecules or ions are irregularly arranged, or they are not arranged in a regular manner. So this is about the crystalline solids and amorphous solids. Over here I have given some examples of a crystalline solid, which is nothing but the copper, silver, then iron, sulfur and quartz. So these are some examples of a crystalline solids. From this figure we can clearly understand, or we can visualize, how the atoms or molecules, we have to consider this sphere as a constituent particles of the solid, which may be atom, which may be molecule, which may be ion. So basically into the crystalline solid we can understand the constituent particles has been arranged in a regular manner into the three-dimensional space. Like over here we can understand this arrangement is a very regular, right, into the two-dimensional space, throughout the volume. This constituent particles has been arranged in regular manner. And when we coming to the amorphous state or amorphous solid, we know this arrangement, there is no any regular arrangement of the atoms, right? There is no any regular arrangement of the atoms. They are arranged in irregular manner. So from this figure we can understand how the solids, in the solids, crystalline and amorphous state has been formed. Now coming to the next concept, that is the single crystalline state. We have learned about the crystalline solid and amorphous solid. Okay, now there is a one more concept is about the single crystalline state. So single crystalline state is a special state into the crystalline solid, where the periodicity is maintained throughout the entire volume of the substance. Means what? There is no any irregularity, or there is no any interruption within the regular arrangement of the atoms, molecules or ions into the crystalline material. So single crystal is again the solid or solid object in which an orderly three-dimensional arrangement of the atoms, ions or molecules is repeated throughout the entire volume of the substance. So this is nothing but the single crystalline state. Over here we can see some single crystalline materials, which is nothing but the diamond and silica. So going ahead, from this figure we can realize the crystalline solids and amorphous solid is there, and over here the new concept has been introduced, which is nothing but the polycrystalline. So then question comes in our mind, what is meant by the polycrystalline? We understand about the crystalline state or crystalline solid, we understand about the amorphous solids where irregular arrangement is there, and in this case regular arrangement of the atom is there, and then this is the new concept, that is nothing but the polycrystalline. So what is the difference between these three? From careful observation we can understand this difference also. So polycrystalline is again the solid or solid object in which the periodicity is interrupted. We can see the periodicity over here, the arrangement is a periodic. Over here the arrangement of the atoms is a periodic. Over here the arrangement of atoms is a periodic. But when we coming to this region, okay, when we are coming to this region, what we can see, clearly see that the arrangement of the regularity of the arrangement of atom has been interrupted. So what it means? It is this region is called as a grain boundary. This region is called as a grain boundary. So polycrystalline is a substance in which periodicity is interrupted at the grain boundary. Okay, so grain boundary is the region where periodicity is interrupted, and polycrystalline is the solid in which the periodicity is interrupted at the grain boundary. So this is about the complete different concept of the crystalline state, then polycrystalline state, and the amorphous states. Okay, so we can over here I want to remind the definition of amorphous state, because we know in a crystalline and polycrystalline state generally a regular arrangement of the atom is there, but into the amorphous state, the amorphous state is the state of the matter in which the constituent atoms, ions, or molecules of the substance is irregularly arranged into the three-dimensional space, or it is not arranged in a regular manner into the three-dimensional space. From this figure, we can understand or visualize how the arrangement of the constituent particles into the crystalline, into the polycrystalline, and amorphous solids. So from this figure we can understand the how the constituent particles are arranged into the three-dimensional space for the crystalline solid, for the polycrystalline solid, and for the amorphous solids. Okay, so over here we can see the regular arrangement is there for crystalline solid. Then over here we can see the this regular arrangement has been interrupted around this grain boundary. So we can see the over here the grain boundary is there where or that region is there where periodicity has been interrupted. So we can see this is the regular arrangement. This is the regular arrangement, and this regular arrangement has been interrupted over this grain boundary region. So this is called as a polycrystalline, and in amorphous state of the solid, we can see clearly seen that the atoms or the constituent particles has been arranged irregularly. In this figure, I have classified the solids in detail. Like I have given these some examples of the crystalline solid and some example of the amorphous solid. In a crystalline solid, there are different types of solids like ionic crystals, which can be NaCl, KCl, then covalent crystal like diamond, silicon oxide, then molecular crystal like naphthalene, glucose, then metallic crystal like we know the copper, aluminium, then the silver, gold, sodium metals. So those are the metallic crystal. Then atomic solids, which can be frozen elements of a group 18. And then coming to the amorphous solid, we know the wood, paper, glass, rubber. These are the examples of the amorphous solids. Thank you students for listening and watching this video.